Flipped classroom video for Maths AS Unit 1, Applications of Tangents and Normals. We've looked at how to find the equations of tangents and normals, but there are also applications of this. For example, we might want to find the points of intersection of the curve and the tangent or normal. We might want to find points of intersection of the axes with the tangent and the normal. We might want to find a point where a curve has a certain tangent or normal. We might want to find equations of tangents and normals with a particular gradient. We might want to prove or find out whether a line is a tangent to a curve or not, and similarly whether it's a normal to a curve or not. So there are a lot of geometrical applications, and given that graphs can describe real physical situations as well, or scientific situations, then these problems become real problems when applied. So these are very useful techniques. Often when we're doing these sort of problems, you will be also using your knowledge of coordinate geometry and of polynomials. So let's have a go at one. Finding points of intersection of the curve and the tangent or normal. This first one is find the equation of the tangent to the curve y equals x cubed plus 2x squared plus 4x plus 4 at the point where x equals 0. Work out the coordinates of where this tangent line crosses the curve. So we have a curve, we draw a tangent to it, and we're going to find out that it crosses the curve somewhere else as well. It touches the curve where it is the tangent, that's what the tangent means, but it also crosses the curve somewhere else, and we've got to find out where. So the first step is we only know the x coordinate at this stage, so we need to find out what the y coordinate is for this point we're dealing with, and that means just putting x into the equation, and that gives us nothing cubed plus 2 times nothing squared plus 4 times nothing plus 4, which is of course 4. Now we have to find the gradient of the tangent at that point. So dy by dx is 3x squared plus 4x plus 4. And when we put 0 into that, so dy by dx when x is equal to 0 gives us 3 times nothing squared plus 4 times nothing plus 4. So that is 4. Then we find the equation of the tangent. We have y minus y1 is mx minus x1. The point we're dealing with has a y value of 4, which we worked out in step 1. So that's our y1. Our x1 is 0, we knew that already, and our gradient is 4, so m is replaced by 4. And when we tidy that up, we get y equals 4x plus 4. But now we have to find where that tangent crosses the curve. Now this is the new bit really, because what we do is we put the expression for the curve, x cubed plus 2x squared plus 4x plus 4, equal to the equation of this tangent, which is 4x plus 4. Now, the next line we can subtract 4x from both sides, and we can subtract 4 from both sides, so that gives us x cubed plus 2x squared is 0. We have a factor of x squared we can take out, so we have x squared times brackets x plus 2 is equal to 0. And that gives us the two solutions, x equals 0, which is a repeated root, and x equals minus 2. Now the fact it's a repeated root is important because that in fact tells us that it's a tangent. The other value we get, x equals minus 2, will be where the tangent line hits the curve again. So we want the coordinates of that, so we then have to put that back into the equation. So y when x is equal to minus 2 is going to be minus 2 cubed plus 2 times minus 2 squared plus 4 times minus 2 plus 4. And you can work that out or bung it into your calculator, and that gives us minus 4. And so the intersection point is -2, -4. That sort of smooth N type symbol is the mathematical symbol for intersection. You may have come across it in probability, but I'm using it here to mean the intersection of the line and the curve. And we can see a picture of that. We can see the tangent at the point 0, 4 comes down to the left and down and hits the curve again at -2, -4. We'll have another example now, and this time we're looking at finding the equation of a tangent with a specified gradient. So find the equation of the normal to the curve y equals 2x squared minus 5x plus 6, which is perpendicular to the line y equals x minus 1. Show that this intersects the curve again at 0.54. So step 1 is to find the gradient of the line and the normal. We're told that the equation of the normal to the curve is perpendicular to the line y equals x minus 1. Now what that means is that if we imagine a line parallel to y equals x minus 1, that is a tangent to the curve, then it would have a gradient of 1, just the same as y equals x minus 1. So we can say that the gradient of the tangent to the curve, wherever this normal hits it, must be 1, and therefore the gradient of the normal, mn, is -1 over the gradient of the tangent, so that is -1. We need to find a formula for dy by dx because we know the gradient, but we don't know whereabouts this tangent would be hitting the curve. So we differentiate. Dy by dx is 4x, which is the 2 times the 2 that comes down, so 2 times 2x minus 5. Find a point on the curve with this value, the 1, for dy by dx. So we need 4x minus 5 equals 1. That means 4x is 6 by adding 5 to both sides. Divide by 4 gives us x is 6 over 4, or 3 over 2. And the y value means that we can put this 3 over 2 back into the equation of the curve. So that gives us 2 times 3 over 2 squared minus 5 times 3 over 2 plus 6. So that equals 3. And that means the point we're dealing with is the point 3 over 2, 3. So next step, find the equation of the normal. Well, we know the point that the normal is travelling through, which is 3 over 2, 3, and we know its gradient from step 1, which is -1. So we can pop that into the y minus y1 is mx minus x1, giving us y minus 3 is -1 times x minus 3 over 2. Multiply the bracket out and add the 3 to both sides, gives us minus x plus 3 over 2 plus 3, which is minus x plus 9 over 2. Then we need to find the intersection of the normal with the curve, because we're trying to show that it intersects the curve again at 0.5, 4. So we put the equation of the curve, 2x squared minus 5x plus 6, equal to our equation of the normal, which is minus x plus 9 over 2, times through by 2 because fractions are a pain, so that gives us 4x squared minus 10x plus 12 equals minus 2x plus 9. Then add 2x and subtract 9 from both sides, gives us 4x squared minus 8x plus 3. Now we then need to factorise that in order to solve it. There's different ways of doing this. One way of doing it is to multiply the x squared coefficient with the constant, which gives us 12, and then find pairs of factors which will add up to our minus 8, which is the coefficient of x. And obviously if we have a minus coefficient there and the 12 is positive, we need minus times minus. So that is our little table, and we can see that the minus 2 times minus 6 is 12, and minus 2 plus minus 6 is minus 8. We can therefore split the minus 8x into minus 6x minus 2x, and we carry on through working out the factorization, and we end up with two solutions, x equals a half and x equals 3 over 2. Now, of course, the x equals 3 over 2 is where this normal is the normal to the curve, because that's the point we already had. So the intersection with the curve again is at x equals a half, which sure enough is the 0.5 that we were asked for. The x equals a half, we could put it back into the equation of the curve, which would be a bit complicated, or much easier, we can put it back into the equation of the normal. And so we get y, when x is a half, is minus a half plus 9 over 2, which is 8 over 2, which is indeed 4. Just incidentally, with the factorization, we could have done the factorization by recognizing that because 3 over 2 must be a solution, because it's the intersection of the normal with the curve, and 3 over 2 is one of the intersections of the normal with the curve, that would have given us the term 2x minus 3 is 0, and that would have then allowed us to factorize perhaps a little quicker. Anyway, we have now shown that the intersection is indeed the point a half, 4. There's a picture of this whole situation. We have the solid green line is our original line, y equals x minus 1. The dotted line is parallel to that, but touching the curve, so it's the tangent to the curve that's parallel to our original line. The normal is then at right angles to that, and the point is 1.53 or 3 over 2, 3, which we found, and then we can see the normal then intersects the curve again at a half, 4 or 0.5, 4. So that's the geometry of all this algebra and calculus we've done.